Guys, good morning. It's another lovely Monday. I hope your day has been going fine. Hope you're having a lovely day. Okay, so today we're going to be looking at Pythagorean Theorem, the second part of what we did in the last class. Okay, so just try to follow the class and try to enjoy yourself and understand. Okay, before that, I want to show you something. This is the riddle of the day. Okay, so the riddle of the day is this. I have a pound of feathers and a pound of iron. Can you tell me which one weighs more? Feathers and iron. A pound of feathers, a pound of iron. Which one weighs more? Which one weighs more? Okay, so as usual, just stay tuned. Towards the end of the class, I'll tell you what the correct answer is. Okay, I'll tell you what the correct answer is. So let's move on. Okay, so we talked about something in the last class. We talked about the Pythagorean Theorem, right? And we said that, okay, let's review the question, but let me just tell you what the theorem was all about. We said that Pythagoras said that in a right angle triangle, the hypotenuse, which is usually the longest side, or the side, facing the opposite the 90 degrees angle, is the hypotenuse. Now, we said the hypotenuse is the longest side, and the square of it is equal to the sum of the square of the adjacent sides. That's the other two sides in the right angle triangle. So we looked at that. We saw some examples on that. Okay, so today we're going to be doing something else. So just, but let's review this. Let me be sure that we still remember this. So I want us to try to find the length of PS here. I want us to try to find the length of PS here. Okay, but let me just say that if we're going to find PS, which is y centimeters, we need to use the yellow triangle, right, to find PS, the yellow right angle triangle. But we don't have X, and X is in the yellow triangle. We don't have X. So what we do instead is we try to find a value for X using the green triangle. Okay, so let's look at how to break it down. Okay, so this is our triangle. So we're going to start first of all with the green one, which is PQR. So in triangle PQR now, we're going to look at we're going to use the Pythagorean theorem there. Okay, so and you know that x squared is the hypotenuse. Okay, so we're going to have x squared equals to 3 squared plus 2 squared. Remember that the square of the hypotenuse is equal to the square of the sum of the square of the other two sides, the adjacent sides. So by the time we do that, we get x squared equals to 9 plus 4. And then we get x squared equals 13. Now, as you can see, 13 is not a perfect square. It's not a perfect square. So we can just leave it like that and use it for the next triangle. Since we're not specifically asked to find x, okay, we can just use it like that in the next triangle. So let me show you what I'm saying. Now I'm going to move to the yellow triangle and we're going to try to find y. Okay, we're going to try to find y now. So now, I think everyone knows how we're going to find y. Now, I think everyone knows how we find y, right? Now, we're going to use the triangle PRS, which is the yellow triangle. We're going to use the triangle PRS. Now, if you look at triangle PRS, you know that y is the hypotenuse in that case. So, from Pythagorean theorem again, we know that y squared equals x squared plus 6 squared. Since y is the hypotenuse and x and 6 are the adjacent sides, okay? So y squared equals x squared plus 6 squared. Now, but you know that x squared is 13 from our previous triangle. So you have y squared equals 13 plus 36. 6 squared is 36. Now, if we evaluate this properly, we should have y squared equals 49. That's 13 plus 36 is 49. And then we have y is square root of 49. And then we have y equals 7 centimeters. So, using Pythagorean theorem in the right angle triangle is not difficult. What you just need to identify is which side are you looking for. Like for this question, we knew we were looking for y, but we could see that until we were able to get x, we could not have gotten y. Okay, so you need to look out for, okay, what am I supposed to find? And is there something else I need to find before I can find what I truly need? You understand? So you need to just be able to go through that process. Okay, once you're able to go through that process and you're able to determine what you're looking for, okay, everything else will be easy once you know the formula. And the formula is A square plus B square equals C square, where C is the length of the hypotenuse. Okay, let's move on to what we want to do today now. Okay, so Pythagorean triples. We're going to start with Pythagorean triples. I talked briefly about this in our last class, where I was saying that in Babylonian times they traced the tablet back to Babylon, and in those times there was a tablet where on that particular tablet there were inscriptions that were later called the Pythagorean triples. Okay, so you at least you heard about what those Pythagorean triples are. But let me just tell you again what Pythagorean triples are. Okay, now Pythagorean triples basically from the name from the name of the expression, you can easily figure out what it means. There are sets of numbers that obey the Pythagorean theorem. That's just it's so easy. There's nothing difficult or so far-fetched about it. Just look at the name of the um, concept, and then you'll be able to figure out what it means. So Pythagorean triples are sets of numbers, three numbers obviously, because you have three sides in the triangle, in the right triangle. So Pythagorean triples are sets of numbers that obey the Pythagorean theorem. It simply means that the square of one of those three numbers is equal to the sum of the square of two of the other numbers. Okay, we will practice that and we'll see how we can check for that and see if it's really true. But let me just show you a kind of some examples of Pythagorean triples, a kind of summary, yeah. So look at this. These are Pythagorean triples: 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, and so on. Now, if you notice something, you see that the ones in red are like the leading Pythagorean triples based on this particular display now. Now, what do I mean by that? You see that the other Pythagorean triples underneath are multiples of the ones in red. For example, 3, 4, 5, 6, 8, 10 is they are multiples of 3, 4, 5. Okay, the same thing, 9, 12, 15 are multiples of 3, 4, 5. Okay, so that's another very should I say unique thing about Pythagorean triples. It's a very unique thing. You can actually find multiples of a Pythagorean triple and they would still obey the Pythagorean theorem. Okay, so but now I want us to now look at, okay, for example, you're asked to find out if this is a Pythagorean triple, or you're asked to complete a Pythagorean triple or something like that. What do you do? So look at this. So let's take a look at this now. So for example, they ask you this kind of question: which of these is a Pythagorean triple? Of course, now you know that Pythagorean triples are numbers that obey a set of numbers that obey the Pythagorean theorem, right? Okay, now you know that. But how do you now show that they are Pythagorean triples? It's easy. You just need to apply the theorem. Okay, so look at this. We have number 1, 33, 56, and 65. Then number 2, we have 15, 30, 35. Okay, let's start with number 1. So now we have this set of numbers. Okay, we're given these numbers and we're asked to check. And these numbers, a Pythagorean, do they form a Pythagorean triple? Okay, so remember that our Pythagorean theorem is a square plus b square equals c square, right? Where c is the length of the hypotenuse. Okay, very good. Now, so if you have been following, you know that the hypotenuse is the longest side, right? Hypotenuse is the longest side, which is c, right? So it's only natural that we should pick the biggest number for the hypotenuse, right? Because we already know that, we say the hypotenuse is the longest side, the hypotenuse is the longest side. So it's only logical that, okay, the biggest number there should be in place of the c, should be in place of c, which is the hypotenuse, okay? But you cannot conclude that they are equal until you get to the end. Okay, let's substitute and just follow me. So we're going to put 33 in place of A now, and we're going to put 56 in place of B. Okay, you can still exchange A and B anyway, but C must be 65 because the hypotenuse must be the longest one. So let's do that now. So we have 33 square plus 56 square. Now we are not sure whether it's going to give us the same thing, so I just put a question mark there. By the time we prove that they are equal, then you can change it to equal to sign. So we're just going to leave a question mark there. Now 33 square we get that, 56 square we're going to get that, and then 65 square we also get that. Okay, so 33 square now is 1089. Okay, 56 square now is 3,136. Oh, now then 65 square is 4,225. Okay, so we've not finished it up, so let's still leave our question mark there. Okay, now let's add together and see. Okay, so 1089 plus 3136 is actually going to give us 4225. So now we can take away the question mark and we can say that 4225 is equal to 4225, right? Okay. Now, if you get answers that are equal, what does that mean? Now, we were able to get answer on the left side as 4225, and on the right side, we also have 4225. And this was done all with the use of the Pythagorean theorem. So what does this mean for this set of numbers? What does this mean? Now, this simply means that 33 and 56 and 65, that the combination is a Pythagorean triple. That's what that means. Okay, so it's not something difficult. All you just need to do is recollect the Pythagorean theorem and apply to whatever set of numbers you're given. And if it doesn't work out, okay, you know what that means. If it works out, you know that, okay, yeah, it's a Pythagorean triple. Let's try the second one. Let's try number 2. Now we have 15, 30, 35. Still remember that our law is a square. Our theorem is a square plus b square equals c square. So we're going to substitute 15, 30, 35 now. Okay, so that's what we've done here. 15 square plus 30 square. Remember that the longest one is the hypotenuse. So we take 35 as our c, since it's the biggest value there. So 15 square plus 30 square, question mark 35. So we've not confirmed whether this is a Pythagorean triple or not. So let's continue. Now 15 square we get that, 30 square we're going to get that, and 35 square we're also going to get that. So 15 square 225, 30 square is 900, and 35 square is 1225. Okay, so what next? What next? 225 plus 900 is 1125, which is not the same as 1225. I hope you're understanding what I'm saying. Now, 1125 is not the same as 1225. So what does this mean for these three sets of numbers? What does this mean for this set of numbers? What does that mean? So let's look at that. This simply means that 15, 30, and 35, the combination is not a Pythagorean triple. Is not a Pythagorean triple. Okay, so any set of numbers, three numbers rather, that do not obey the Pythagorean theorem are not Pythagorean triples. So it's as easy as that. All you need to do is check, does it obey the Pythagorean theorem? Okay, oh yeah, it does. Okay, it's a Pythagorean triple. Does it not obey the Pythagorean theorem? Or it doesn't obey, so it's not a Pythagorean triple. It's as easy as that. Okay? It's as easy as that. So also, if you're asked to complete a Pythagorean triple, you can also apply the Pythagorean, theorem and try to get the third side that you're asked to find. The same way we apply it to triangles, right? Okay, but I want us to move to something more interesting now, something more fun. So let's look at this. Now let's talk about applications to daily life. When we are doing topics in mathematics, we should always note that these things are actually calculations that we need in our daily life. They are things that actually are not abstract. We can actually use them. You understand? They are things that we actually need to use in daily life. So you always need to ask yourself that question when you're dealing with a particular topic. Okay, try to research. How do I use this in my daily life? Now, some of the topics might be leading to another topic. There might be a foundational topic for another topic. So you might not necessarily find some applications, directly. But when you apply it to those other topics, you see the application in daily life. So always try to ask yourself that question. Okay, what is this topic going to actually help me with? It will show you a lot of fun, and you see a lot of fun things that you didn't even think of before. Okay, so let's look at this now. Now, for example, let's call these people, let me just give them names. So let's assume this is Luke and this is maybe Chad. Okay, Luke and Chad. So Luke and Chad, Luke is the one with the red hard hat, and Chad is the one with the white hard hat. Now, let's assume that Luke and Chad are working at the same firm. Now, they're working in the construction company, and then they're on site one day, and then someone walks up to them and says, okay, my name is let me see, Sylvia. My name is Sylvia, and I'm actually trying to, I'm building a house. I've been working with some other construction workers previously, and I need a new face, or a new person. Okay, and I need you to help me do something. I have a house. Okay, let me now show you the next picture. So Sylvia says, I have a house, and okay, I need to do something on the top of my house. I need somebody that will get on the ladder and climb that ladder and do something on the wall of my house. For example, that's just an example, okay? So now these construction workers are like, okay, Sylvia, we're going to look into it and see how we can help you, okay? We're going to look into it and see how we can help you. Now, let's get into the dimensions of the question now. Now, the ladder that is here, the ladder that you can see now, we're just making assumptions, okay? The ladder that is shown is 37 meters long. That's the length of the ladder is 37 meters long. And they know already that, okay, the foot of the ladder is 12 meters from the wall. The foot, that's the base of the ladder, is 12 meters away from the wall. And then they want to know how far up the wall the ladder can reach. Okay, so it's a practical thing. Now let me just tell you put this in another form. So Chad and Luke, okay, they say, oh, we have a ladder. Our ladder is 37 meters long. Okay, now this is just, yeah, we're just assuming figures, okay? So our ladder is 37 meters long, and then if we're able to tilt this ladder at the appropriate position where it will be safe for us to climb the ladder. Now, when we tilt the ladder, the foot of the ladder is usually 12 meters away from the wall, okay? So we want to, they are talking to themselves that, okay, how far will we want to know how far up the wall we'll be able to reach, because, we need to know the specifications that Sylvia is also, looking at. So how do they solve this problem? They know the length of the ladder. They know, okay, this is how long our ladder is. They've been using it for a while. And then they also know that, okay, if we tilt the ladder on the wall, this is how far the foot of the ladder is usually from the wall, okay? So the only thing they don't know is, okay, they want to know how far up the wall the ladder will be able to get. So that is the problem that Luke and Chad want to solve now. Now let's assume that Luke and Chad actually had some experience with mathematics. They do not have to go so far to solve that problem. All they need to do is use the Pythagorean Theorem. That's all they need to do. Now let me show you how we can interpret this question. It's a 3D, it looks like a 3D picture, right? Let's now see how we can bring it down to 2D. Okay, follow me. So look at this. So this is our ladder, right? Let's analyze. This is our ladder and everything. So this is the length of the ladder. You can see the purple line. Let me do that again. Okay, so this is the length of the ladder. You can see that purple line there. Okay, now the length of the ladder is 37. We've said that already. The length of the ladder is 37. Now look at this. Now let's talk about the distance from the foot of the ladder to the wall. Okay, so this is the distance. The blue line there is the distance of the foot of the ladder to the wall. Okay, I hope you can see the blue line there. So, and that distance was 12 meters based on what we were given. So the length from the foot of the wall, from the foot of the ladder to the wall is 12 meters. Okay, now what are we looking for? We're looking for how high up the wall does the ladder reach. Okay, so look at the red line now. Look at the red line. So the red line is how high up the wall the ladder actually reaches. And we do not know that value, do we? No, we don't know that value. Okay, so let's just say question mark. That's what we're looking for. How far up the wall does the ladder reach? Now, I want you to look at the colors alone. Look at just the colors. Forget about the ladder and the other colors in the picture. Look at the 3 lines that we have drawn. What shape does that look like? What shape does that look like? It's a triangle. It's a right angle triangle because vertical to horizontal, the angle between the vertical and the horizontal is usually 90 degrees. Take note of that. So what we just succeeded in doing is we've been able to get a right angle triangle. Okay, we're able to get a right angle triangle from this problem. So Luke and Chad don't have to start thinking, okay, let's go to a house, let's measure the wall, let's do this, let's do that. All they need to know is, okay, how long is their ladder? What's the distance between the foot of the ladder and the wall? And with that, they can calculate the heights of, how high up the wall the ladder will be able to reach. So you can see that Pythagorean theorem is actually not abstract. There are many other applications. This is just an example. Okay, there are many other applications. In fact, I would actually dare you to search for more. That's a dare. Search for more. Okay, so how far up the wall does it reach? Let's now bring this down into a two-dimensional problem. Okay, so our triangle is like this now. Okay, so let's call the side that we don't have the x. So we have 37 meters, 12 meters, and we have x meters that we are looking for now. So what do we do from here? Remember, a squared plus b squared equals c squared, where c is the length of the hypotenuse. Okay, so we have our theorem there, then we can start solving. So that simply means that 37 squared, okay, 37 is the hypotenuse, equals to x squared plus 12 squared. Okay, so then we have 1369 equals x squared plus 144. 12 squared is 144. Okay, so we can take 144 to the other side, and we have 1369 minus 144 equals x squared. Okay, I hope you're following me. 1369 minus 144 equals to x squared. Now, x squared, we can just turn it upside down. 1369 minus 144 is 1225. So x squared equals 1225. Okay, now but we need to now find x. So x will be square root of 1225, and that should give us 35 meters. Okay, that should give us 35 meters. Okay, so our answer there is 35 meters. Now, like I said, I actually dare you to actually look for more, more applications. So you see some questions on maybe a concrete slab, something underneath the slab. Now let me just tell you the key to knowing how to which one actually works and which one doesn't work. Now, when you are able to see, if you're able to see a problem and you're able to identify a right triangle, from that problem, it's something you can get out of that problem, then you can use the Pythagorean theorem. But if you analyze the problem and it's not giving you, you're not able to get a right triangle out of it, then of course you can use the Pythagorean theorem. Okay, so there are some problems in daily life, if you actually try to research and find more, that need us to plot a triangle and see how we can actually get maybe one of the sides. Okay, and that's when you now use this Pythagorean theorem. So it's not abstract. It's not just about learning the formula and then just going with the formula. You can actually find out how it helps you in daily life. Now, I gave you guys an activity the last time. I gave you an activity the last time that involved, using a right triangle and then drawing squares on each side and then counting the squares. I hope you were able to do it, and I hope you were able to count the squares, and I hope you actually got to prove the Pythagorean theorem. Okay, that's a rough way to prove that a squared plus b squared equals c squared in the right triangle. It's a rough way to prove it. So you don't just need to learn the formula. Sometimes you need to actually try to find out, be innovative and try to find out how did they derive this formula. Of course, there are some formulas whose derivations are too, advanced for your level, but for anyone that you can try to understand, do that. It's fun. It's fun. Don't put pressure on yourself, but just try to see, okay, how did they actually arrive at this formula? How was this formula actually obtained? Okay, so that's that for Pythagorean triples and also the applications of daily life. So remember that Pythagorean triples are sets of numbers, or a set of numbers rather, that when you use the Pythagorean theorem on them, it actually works. So they actually obey that theorem. Okay, so I want us to just look at a brief summary now. A brief summary of everything. So what have we learned today, or what have we been able to look at? Okay, first of all, we remember that I've said this over and over. Pythagorean triples are sets of numbers which obey the Pythagorean theorem. They are sets of numbers which obey the Pythagorean theorem. C squared equals to a squared plus b squared, or you can say a squared plus b squared equals c squared. It's the same thing, okay? But remember that c is the length of the hypotenuse. Very important. Okay, now also we have also learned that the Pythagorean theorem can be applied to our daily problems that we encounter in life, which can be translated to right triangles. So any problem that you see that it's something that, okay, I can get a right triangle out of it, then why not? If I'm looking for one side, I should be able to use the Pythagorean theorem. Okay, like I said, I dare you to find more of this. and let me know if you found any. Okay, so what are the steps when we want to look at these problems, these daily life problems that we want to use Pythagorean theorem on? Okay, step one, the first thing is to analyze the problem. You can see the one we talked about with the ladder and Chad and Luke and Sylvia and the house and all that. The first thing we did was to analyze, okay, what did they have? What were they trying to find? How did the triangle come out? You understand? So analyze the problem first of all, and then try to bring out a right triangle from that problem. That's the first step. Okay? Now, step two is the easy one, the easy part that we already know. So you apply the theorem to find the missing side. Apply the Pythagorean theorem to find the missing side. Sometimes it might not be like this particular application we dealt with, we were looking for how far up the wall the ladder was able to reach. Now that was one of the adjacent sides. Sometimes you might be actually asked to find, when you interpret and you analyze, you might be looking for the hypotenuse, okay? So it doesn't matter whatever side is missing, but just use the theorem to find the missing side. So another thing is, there are so many Pythagorean triples. There are lots and lots and lots of Pythagorean triples. Okay, there are lots of them. The ones I displayed for you are just, a pinch out of the Pythagorean triples. So there are so many of them. Okay, just take note of that. Now, so simple, very easy. I think today's the second part of Pythagorean theorem is actually very short. It's not much of a big deal. Okay, now. Okay, so now let me just show you the answer to our riddle. Okay, so I asked you a question and I said, I have a pound of feathers and I have a pound of iron, and I said, which one weighs more? Okay, the simple answer is neither. I want to believe some of you have actually thought about the correct answer and you were able to get it in your head. That's nice. So the actual answer is neither weighs more. A pound is a pound. The temptation here is that we all know that in general, iron has more weight than feathers. A piece of iron will obviously have more weight than one feather, one piece of a feather of a bird or anything. But the real thing here is that in this case, you were given the measurement already. You were told that you have a pound of feathers and a pound of iron already. So you don't need to start using that, understanding of the usual weights of iron and of a feather. So the answer is neither weighs more, because a pound is a pound, whether it is feathers or iron or whatever. So that's the answer for that. Okay. Now let's look at something I want you to go with today. Okay, something I want you to just do, take a look at it. So research on Pythagorean triples. We talked about some. I just mentioned some 3, 4, 5, 6, 8, 10, 5, 12, 13, and so on and so forth. Now, like I said previously, there are so many of them. And there are other fun facts that you can actually find out about Pythagorean triples. So I want you to actually research, just go and search on Pythagorean triples, look for fun things you can find on it, and feedback. Give me some feedback on, what you were able to find. There's so many of them. There's one particular, let me just give you something now, like, should I say it's like a bait? I don't know. So there's one particular number that is very common in a lot of Pythagorean triples. It's a very big number, I know. It's very common in many, it cuts across many Pythagorean triples, very many. I want you to try to tell me what that number is also. So research and just try to tell me, if you research well, you see that particular number. And tell me what the number is. Okay? Now also, I want you to do something else good. Visit quizzes.com if you can, okay? Visit quizzes.com and try to play some games on the Pythagorean theorem. Just play some games. I think I told you to do this in the last one. So look for games now that have every single thing about Pythagorean theorem, including Pythagorean triples and applications to daily life. So like I said, I dare you to find more applications. And I dare you to always find applications to real life in anything that you're taught. I dare you to do that. Okay? So it has been fun today. Today's class is quite short, okay? So it has been fun, teaching you guys today and, just talking and, communicating with you. I hope to hear from you if you have comments on, what we've done today, you want to understand something further, or you want more explanation on something, let me know. If you have any other thing you want to say, let me know. Okay, so don't forget to like. You can also comment and share, and also subscribe for more updates. Now, in our next class, we're not going to be talking about Pythagorean theorem again. We're going to say bye to Pythagoras, and we're going to do something more, not necessarily more fun, but something fun anyway. This has also been fun, I think. So just do something else that will also be fun. Okay, so we're going to end the class here for today. I hope you have a lovely day. Take care of yourselves. Bye.